Hello, class. Happy week 8. Wow, isn't that great? So, what's on tap for this week? I already set you guys up with the templates and tutorial for this latest problem set 4. Remember, the tutorial video is on the very first worksheet, and you can use that template workbook to submit and do all your work and submit into the assignment folder into Leo. Again, if you have any questions about those questions, let me know, but it should be pretty straightforward in the video. So this week, content-wise, we're getting to more hypothesis testing with two populations. What does that mean? That means there's like two groups. So for example, the difference between males and females on whatever, or the difference in sales between 2 or 3 or 4 or more cities. Anytime you have multiple samples like that, that's when we start doing things like t-tests and ANOVAs. Now there's a unique instance where we have this concept of the paired data, and if you don't know what that means, it's literally the data is paired per respondent or record. So like a pre and a post test, you know, your pre-weight, your post-weight, like in a clinical trial, you would have some sort of pre-test, post-test design, basically judging the efficacy of a medication, sales before and after a particular marketing event or campaign. But the data, there's always 2 or more pieces of paired data for an individual record. I like to think of this in terms of rows. Okay, so each record is unique, each row is unique, and then you have multiple columns that belong to that record, but they're usually similar data points, okay? So time series data would fall along those lines as well. Now, when we get into categorical groups, let's take, for example, and let's choose an example like this has 3 or more groups. That's when things get a little tricky because you can just do a mean comparison, okay, when you have like 2 groups, but when there's 3 or more, that's when you got to start thinking about comparative tests, post hoc tests they're called. That's where you'll see that Tukey-Kramer test. So that would come after you did a t-test or an f-test, ANOVA, to look at the differences between 3 or more groups. What that Tukey-Kramer test does, it looks at the comparison. So if there's 3 groups, it compares 1 to 2, 1 to 3, and 2 to 3. Does that make sense? So every possible comparison, and tests whether or not those group differences are all statistically significant. So you can say, well, yeah, the difference between 1 and 2 is not significant, but the difference between 1 and 3 is, and vice versa. The difference between 1 and 2 is not, but the difference between 2 and 3 is, and so on and so forth. I don't know if I just repeated myself, but hopefully that makes sense. That's when you would use the Tukey-Kramer. There's another type of test called the Bone-Ferroni, which does the same thing for pairwise comparisons. We don't have any examples just yet that I can show you, but I can tell you one more thing. When it comes to group data and categorical data like that, Excel needs you to arrange the file in a special way. So you can't just say like the first 10 records are males and the next 10 records are females. You actually have to say this column of data is males, this column data is females, vice versa. If it's like cities, this is Denver, Seattle, New York. You can't have it stacked like that. Whereas if you use an actual statistical software application, you would do that. But Excel, for some reason, requires you to chunk the data of each group as separate columns. So just a heads up, when we cross that path, you got to know, you got to restructure the data, the groups into separate columns. Okay, in hypothesis testing, remember, there's always a null, always your alternative. The null is no difference, it's the given. Your alternative is what you're really interested in. If there's some sort of difference, positive or negative usually, and that's what tells you your tests. Your left tail, negative, right tail, positive. If you really don't care, if you just say there's a difference between whatever you're testing, you would go with a 2-tail test, okay? Okay, so that's it, folks. Week 8. Let's make it great. If you have any questions, just ask. Oh, one last thing. This critical article review assignment, I know it's on your minds. Like I said, here's the thing. This is what I'm going to offer you. You could choose to do nothing. Okay, do not do the assignment and get an 85. Or you can choose to do the assignment, try to make it as spectacular as possible, do the critique. You know, and the big thing when you come to critiquing research is if you were to do the research over again, what would you do differently? So you would start to critique things like the sample size, who was sampled, when they were sampled, what kind of measures were used, were they valid, are they reliable, those sorts of things. So I'm just putting it out there. There's your option. Either not do the assignment, get an 85, great, which I strongly recommend, or try to do better than 85 and do the assignment. The key to that is if you use that little grade calculator that you made in the first assignment, that should give you the answer on if you were to plug in an 85 or greater on what you should do. All right? All right, folks, that's it. Let's have a great week.